you have this kind of problems with you, please share in the comments so that I can solve in the next videos and I can share those videos with you. Okay. Yeah. Thanks for watching this video. Yes, I will continue with my video. Okay. So first thing is welcome to solve my quiz. Okay. So first thing, what is a problem statement? So problem statement is how to delete given node from the single linked list. Okay. I think everybody knows what is single linked list. This video is not about explaining single linked list, but yeah. So this video is about explaining the problem statement which has been given for single linked list. Okay. So the problem statement is how to delete given node from single linked list without header. Okay. So first, to understand this problem and to simplify this problem, what we will do is we'll try to delete a node from a single linked list with header. Okay. So that way we will understand. So how we can delete a node from the single linked list. Forget about the with header or without header. First, we should know how to delete a node, right? So for that, so I have just added one presentation layer here. So just see this. So I have 6 nodes in a single linked list. So as we all know, so there will be header node. So header means the first node. So whichever is the starting point of your single linked list, that we call it as a header node. So, and we all know that single linked list, each node will contain 2 fields. First field is a data field and second field is address field. So in data field, I'm just storing A, B, C, D, E, F, something like that. And address field, so I'm just storing the address of the second node. So this 2 means the address of the second node. 3 means address of the third node. So that's how I'm just storing in these nodes. So now the problem statement is we have to delete a node from the single linked list. Assume that this is a single linked list and these are 6 nodes and you have all the connections, right? So now you are going to delete node 4 from the list. So how we can delete the node 4 from the list? So if we know the header, so assume in this case we know the header, what we can do is we can iterate through this list and we can match the data and we can delete that particular node. Assume that every node having a unique values, no value is repeating in this list. So just for simplifying the problem. Okay. So now each node is having the value and address of the next node, right? So we will be iterating through first node and we'll going to second node and we'll compare the data in between, right? So I given the data D. So wherever D is there, you have to delete, or else fourth node, you have to delete it, right? So first I'll go to header and I'll compare the data. It's not D. So I'll go to the second one because I have the address. Then I'll compare the D. I can delete this. I can go to the third one. I'd have C, but I have to delete D. So then I'll go to the next one. So here I have to delete this particular fourth node. So now what we can do to delete this particular node, simply we can ignore this particular node from the list. So how we can ignore that particular node? That is simple. So what we have to do is whenever you are coming from the header node, and once you are reaching this particular node, you know that from where you are reaching it, right? So this particular node is matching means that previous node is pointing to this particular node. So what we can do is, so this particular node, so wherever this guy is going next, so that next address you can take and just you can put that next address in the previous address. So like, so the third node, so which is having the fourth address. So now we don't need this fourth node. So what we have to do, simply we have to make this as 5. Now what will happen? This connection will be eliminated. And this node will be removed from the list. So now what will happen? When you iterate through it, A, B, C, then there won't be any D and it will directly go to the 5 because we are not pointing to the 4. So it is pretty easy if you know the header. But the problem statement is there is no header given to you. You have to delete the fourth node, and only the node which you have given to you is fourth node. So you cannot find the header. So you don't know the header. Okay. So now we'll go to the next slide. So in the next slide, see, I am just depicting the problem statement. So we know the fourth node, but we don't know what are the previous nodes. There might be nodes, but we don't know. There might be n number of nodes, and we don't even know that this is a fourth node. Okay. So but we know the next nodes. How? Because fourth node will, so this node will contain next address. Okay. So now see here, I am not putting any links, and I am removing completely these three nodes from here, because we don't have any information about these three nodes, right? So now we have to delete the fourth node. How we can delete it? So previously we know the third node. That's where then what we did, instead of fourth address, we were pointing to fifth address. But we don't know the third node now. Third node always points to the fourth node, and that means previous node. Whatever the node we are going to delete, that previous node always points to that node whichever we have to delete, and that we cannot change because this node address we don't have. This is anonymous for us. Okay. So in this case, the solution is simple. So what we have to do is we have to eliminate fourth node logically. We cannot eliminate it physically, but we can eliminate it logically. So in software context, whatever the node or any list or anything, whatever concept you have, that is there to handle the data. So overall thing is to manage the data, handle the data. So data is the prior thing. So data is the main thing, right? So logically we have to eliminate this node. So for that, what we have to do, if we eliminate the data from this node, so that we will be achieving the deleting of node. So we cannot physically delete this particular node, but we can logically delete this node. How we can do that? So simply what you can do is you can just copy the fifth node data to fourth node. So what I'm telling, just copy the fifth node data to fourth node. So now fourth node, what it will happen? In the fourth node, I will be copying the fifth node data. Then what I will do is, because I know the fifth node, so I can copy the fifth node data to fourth node. Then what I can do is I can remove the fifth node. Now already I have fifth node data in the fourth node. Automatically I erased the fourth node data, right? So now what I can do is I should know where the fifth node is going next. So fifth node is pointing to the sixth node, right? So directly I can take this address and I can put it here. Now what will happen? The connection to the fifth node will be eliminated. So this might be pointing to sixth node, but we already copied this data to fourth node. So but what will happen? So whenever they iterate, because we don't know how many nodes are there previous to this particular node, right? So whenever they iterate it, what will happen? It will go to this A, B, C, then D is, so this previous node will point to this fourth node only, right? So but in the fourth node, what will be there? The data E will be there. The data which is there in the fifth node, that will be there in the fourth node. So logically, we are deleting the D fourth node, which is having the content D. But physically, which one we are deleting? The fifth node. Okay. So this is the way we have to solve this kind of problems. So at the end, you will have 5 nodes because we are deleting the fifth node. So at the end, you will have 5 nodes, but logically we have deleted the fourth node. Okay. But physically we have deleted the fifth node. Okay. So this is all about this problem. So how we can achieve, so how we can write code for this particular problem. So I'm a Java developer. I have 8 years of experience in Java code writing. So I can explain you in Java code how easily we can write this particular code. Okay, so first, so what we need nodes, right? So just create a node class. So I'm just creating a node. What will be there here? So you need a data field, right? So I'm just assuming string is my data field. Okay, so I'm just making it as a public so that I can access it from anywhere. Then what I can do next one is I need address of the next node. So for that, what I have to create, either I should have a reference or I should have the next node in this particular node, right? So I am creating a node. So I'll name it as a next. Okay. So let me create the constructor for this. One more constructor I'll create just in case. So if you are creating the last node, so there won't be any next, right? So just create one more constructor. Okay. So now we have node. So now we will create a class to create that particular kind of problem, right? So we'll name the class as delete node without header. We take the static void name. So now what we have to do, we have to create the nodes. So how many? In the presentation I have showed 6 nodes. Let me create the 6 nodes. This is a node 1. Which contains data A and the node 2, but node 2 is not available, right? So let me create the node 2 first, because I need node 2 in order to create node 1. Later also I can assign, but I have a constructor, so why to waste code? So I'll just create node 2. So now I can put node 2 here. Okay. Now I have 1 and 2. Let me create 3, 4, 5, 6 as well. Okay. So now this is a 3, 4, 5, and 6. So in our so node 2, where it need to point? Node 3. Node 3, node 4. And data should be C. Node 5. Data should be D. E. Node 6. And this one will be null, obviously. So we don't need to send any data. We already have a constructor. So yeah. So now, so how we will know that all these are connected? Simply, just will print it to see whether our singly linked list is formed or not. So what I'm doing here, I'm just printing out the nodes. I'm just printing the data. I don't want to print the next node address, everything. So now the temp equals to temp dot next. So now, so what we are doing here, we are just printing out all the data in our singly linked list. So node 1 is connected to node 2. So I'll print the node 1 data. Then node 1 dot next means node 2 will be assigned to temp. Sorry, here I can use the temp. So now temp will contain node 2. Then it will print node 2 data and it will So node 2 dot next means node 3. So it will keep on iterating until it gets the null. Okay. So let's run this. So if you see here, A, B, C, D, E. Okay. So 5 only printed because fifth one it's not printed, right? Because we are checking temp dot next. Or else we can directly simply check the temp only. So what will happen whenever the temp is null, automatically it will not enter into the loop. So, but now we are doing temp dot next should not be null, right? So temp dot next means fifth node is fine, but sixth node is not good. It's not. Sorry, it will not enter into this particular loop. Sorry. So here it should be F. Okay, so now all the nodes are connected perfectly and it is printing, right? So now we will see the problem statement. So now the problem statement is they'll give the node and they will not give the header, right? So now what we see is we have node 4. This is the node which has been given, right? So now what we have to do, we have to simply delete this node 4 and everything should be as it is, right? So we already saw when we ran this, everything was printing A, B, C, D, E, F, right? So now D should not be printed in this particular list if we delete this. So now we know the node 4. So from node 4, we know the node 5 also. That means next node, right? So next node is node 5. So we might not know it is a 5 or 4, something like that, but we know that current node is this one and the next node will be having given, it will have the next node address. Okay, so we'll store that in the some temporary variable. So already I have a temp, so I'm storing it in the temp. Okay, now I have delete whichever the node given to delete that node data and the next node data in the temp. So node 4 is the current node which we have to delete and the next node is a temp. Now what I have to do, simply I have to copy next node content to current node, right? So and what I have to do, I have to eliminate the fifth node. So basically that is next node of my current node, that is temp. So node 4 dot next equals to temp dot next. So now what it happened? So logically we have eliminated the node 4 data and physically we have eliminated the node 5. That means deletable node next node. Okay. Now if you try to print this, so we'll start printing from the header. So we'll just copy paste this logic here. It should be. So now temp should print from the header. So that means node 1. So when you print from the node 1, we should not contain the node 4. Okay, let's run this. See this. We don't have D. A, B, C, E, F is there. D is deleted. And they have just given the node 4. We don't even know the header node. This is pretty simple. What we have done, just we have copied the data from the next node to current node and we have physically eliminated the next node. Yeah, that's all about this problem. This is a code. This is a pretty simple. You can answer if somebody gets this kind of question in the next interview. I hope everybody a good luck. Thank you. Thank you for watching this video, and please subscribe my channel. I'll share more puzzles like this in next videos. Thank you. Thank you so much.